meeting is being recorded.
I'm going to resume the recording.
This meeting is being recorded.
And the recording of this webinar is going to be available on our website. I can show you where that is when we go through a little demo of the dashboard. But this will be recorded, so don't feel like you have to remember everything that I'm saying or where everything is, because you'll have access to it after we finish. If you have any questions, feel free to leave those in the chat. I will pause periodically just to see what questions we have and if I can answer those as we go. And if not, I'll leave a little bit of time at the end to answer those questions before we wrap up. And finally, if you don't already have a free account with us, then please go to tuvalabs.com and sign up for a free account. All of the resources that I'm going to show you today are free. They don't require a premium account to access. So if you sign up while I'm kind of doing my intro spiel, then you'll be able to follow along with me as we dive into some of the data stories that we'll look at today. So let me begin by introducing myself. My name is Colleen McInerney. I am the math specialist at Tuva. I started this summer, the summer of 2022. Prior to that, I was in the classroom. So I was an algebra teacher and primarily a math teacher, although I did teach 3 years of earth and space science, but 7 years of algebra and a couple years of geometry, and then some 8th grade Common Core math in there as well. I also spent 3 years working in high need schools, coaching teachers from kindergarten all the way through 12th grade. So have been in a lot of classrooms in different settings and familiar with math curriculum across grade levels. And here I am at Tuva, and I'm really excited to talk to you all today about data stories, something that we kind of have started doing anew for math. And I think that there are a way to make a really manageable way to make high impact in terms of data literacy in the math classroom. So I just want to frame a little bit about our philosophy here at Tuva and why we, focus on data literacy as a way of teaching math content. So we believe that math instruction today relies really heavily on procedure and repetition. And while those obviously have their place, students are often introduced to math concepts without that real world context. So they're taught algorithms or procedures for doing something, but they aren't necessarily introduced to why those concepts that they're learning relate to the real world in a way that's like really authentic. Often you'll see real world problems that both teachers and students, I think, can agree are not authentically real world. And we believe that that lack of real world context has consequences for students in their math education journeys. We think that it leads to lack of student engagement and confidence and enjoyment in mathematics. And without those pieces, it's unlikely that a student will persist in their math education journey past whatever is, required as a basic requirement of them in high school. This last NAEP testing was obviously a huge reality check, I think, for us in education, especially in math education. Students are reporting record high levels of low confidence in math, enjoyment in math, and obviously scores are going down. And there are a lot of reasons for that, COVID pandemic being chiefly among them. But we believe that part of what's driving those scores is a lack of engagement and a lack of connection between students' students' instruction in math and then real world application. So we see data and real-world data as a way to kind of bridge that gap between what students are learning in the classroom as part of their core curriculum and their prior knowledge that they bring to the classroom just from being humans in this world and experiencing data on a daily basis. So we think that putting real-world data in front of students can really lend that authenticity to an existing math curricula. So we're a totally supplemental product. Like, we are not aiming to fill every math standard that exists, but we do think that through the use of real-world data, we can enhance and take real-world application like 10 steps further than a normal math curriculum. Because students really construct their knowledge of mathematics based on their ability to relate it to their lives. And there's been some research, some pretty clear research in the data science, data literacy field that shows that when students are introduced to data sets that are on topics that are either interesting to them or where they can see the real world connection, that really drives student interest and cross-curricular understanding. So, a lot of our math lessons may also kind of have a science focus or social sciences focus to really bring home that math exists in other content areas and not just in this sort of like abstract algorithmic way. So a little bit of context for like why we think data and data literacy is so important in math. And we at Tuva define data literacy as the ability to visually explore and analyze data in various forms, to ask questions of data, and to use it as evidence for argumentation and decision making. And so we've developed these data stories that we think are really good vehicles for getting at specifically this data literacy piece of working with real world data. So a little bit about what our data stories are. They are learning experiences that give students really quick data to either analyze or visualize and make sense about in a really like short way. So these learning experiences are not like our activities. If you're familiar with our activities, those are generally longer and more in depth that actually have students manipulating data sets, where our data stories are really meant to be more like that kind of quick reading of a graph, being able to interpret it and tell a story based on it. And they really focus more on that like argumentation and or writing like true literacy piece, that rather than being able to kind of like apply math content through the use of data. So you'll see as we go through, I'm going to demo 5 different types of data stories that we have in our library right now, again, all of which are free, so you can access them without a premium account. And you'll see that it's very much less focused on content and on content standards and more about like argumentation and reasoning and talking about data. So these are some ways that we think that data stories engage students. So they engage students by prompting them to interpret a specific aspect of a data set. So they may be given truly just like 1 or 2 visualizations and asked to interpret and make some kind of like understanding from that aspect of the data set. They also support students in asking questions about data or interpreting patterns. So again, being able to like not just look at a data and apply some mathematical concepts, but actually talk about it in a way that's cohesive. They help initiate classroom discussion around some kind of real world topic. And then they also foster literacy and writing skills and argumentation, asking students to actually explain their thinking around math or around the data in the context of maybe some kind of brief math content. So we have 5 instructional strategies that we are using to create our data stories. And we didn't invent these strategies. These strategies come from best practices in math instruction. They are well researched. So, we didn't pull these out of thin air. Each of them kind of serves their own purpose in students' development of data literacy skills and math argumentation and reasoning skills. So the first one that we'll talk about is called critique, correct, and clarify. The next is called alike and different, or same and different, similar and different, kind of exists in other names in the math community. Which one doesn't belong? Claim evidence reasoning, which is not obviously not specific to math. We also use that as in our science data stories. You could use it in the social sciences as well. And then also notice and wonder, which is, again, not specific to math, but probably a strategy that everyone here is already familiar with. Okay, so before I dive into each of the data stories, I wanted to pause and just give everyone a moment, if you haven't already, to log into your Tuva dashboards so that I can show you where each of these data stories is, and that way if you want to take a look at them while I'm kind of demoing each of them, you can follow along with me in your own Tuva dashboard. So you can head to tuvalabs.com, and then on your dashboard, you can head to our content library. We are going to focus just on our math lessons today. And I'm going to, at the top here, just uncheck activities. And then these are all of our data stories that have been tagged with math. So I will point you to specific ones in my demonstration as we walk through each of the 5 instructional strategies. So the first instructional strategy that I want to talk about is called critique, correct, and clarify. And this instructional strategy is actually comes from an English language learner best practice, in which students are given a piece of writing that is not their own, and they go through this sort of iterative process of making that piece of writing or that argument more clear and more correct. So they're gonna, and then clear up any misconceptions and or like ambiguities in the piece of writing that they were given to begin with. So they go through this process of looking at it, deciding if there's anything that the author has stated that isn't clear. If so, they can go ahead and rewrite the claim or the argument in order to clarify it. Then they're going to look at the actual data and decide, is this correct? Like, based on the data that we have, is the argument that's being posed here actually correct? And if it's not, what will we need to do to correct it? And then finally, they're going to critique it for like any other way that they would phrase it that would make it more clear to the audience. So then at the end of this process, they rewrite the claim or the argument so that it better reflects the data and is easier for the audience to understand, less ambiguous, and it is correct. So the data story that we have for this is critique, correct, clarify, bones or no bones day. So I have to give a little bit of context about this data story because it will make sense, probably makes more sense to students than it will to teachers unless you are familiar with this dog. But this dog is, or was, because he sadly passed away a couple of months ago, this dog was TikTok famous. His name is Noodle, and he had millions of followers on his account, really his dad's account. Yeah, Noodle's the best. He's so cute. He was this really elderly pug, 14 years when he passed. But every day his dad would pick him up and let him go. And if Noodle stood up on his own, it was called a bones day. Noodle had bones that day. He had enough bones to stand up. If Noodle fell back down to the ground and flopped on his bed, it was called a no bones day. And that was sort of like an omen to the world to take it easy and not try too hard. Okay, so we have a data set from TikTok that looks at all of students' bones and no bones days. So the original argument that students are going to analyze is Noodle was most popular for his no bones days rather than his bones days. So this is the argument that they're going to look at. And actually, I'm going to pause and go back and talk about just what we have here on before we even get started into the activity. So when we have on our data stories, you're always going to see a teacher overview where you can see all this information, this context that I've just given you, and then all of the questions that students are going to be asked. You can also see the mathematical content that this data story is attached to. So students should be somewhat familiar with interquartile range, median, and mean in order to complete this activity. And they also will need to be familiar with outliers, or this data story kind of touches on outliers. Again, because this is focusing more on data literacy and argumentation, it's less tied to content, but this could also get used to reinforce content around these specific topic areas. We're going to use box plots and dot plots in this data story. So those are the aspects of the graph that they're going to need to be familiar with. And then this is suggested for grades 6 through 8. So somewhere in that middle school range, this is appropriate for. Okay, going back to the argument. So this is the original argument that students are going to have to critique, correct, and clarify. And so students are asked before they even look at any data visualizations, is this argument clear? So they need to think critically about sort of the word choice that someone's using in this. And, if you were to just read this argument, would you know what the author is asking? So if there's anything unclear in here, for example, what do we mean by popular? Like in the context of a data set, what would we look at to decide if something is popular or not? And so we may add some clarification in there around, the word popular or other aspects of the argument that are not initially obvious to us. And I will just say that as students get familiar with these different instructional strategies, they may need a little bit more guidance. Oh yeah, absolutely. Let me zoom in a little bit. So they may need a little bit additional prompting. You may, and if you're working with students, you probably know who those students are who might need a little bit additional guidance around this. And other students may just be ready to dive in and give some clarification. Then they're asked to actually do some manipulation to the graph. So when we introduce them to a data story, data stories will be really about 4 steps long, so super quick, but they will always kind of be asked to perform one or 2 steps within our tool in order to get them familiar with what the data set is about, what it's asking them, and just to manipulate the data in some small way so that they feel that connection to the data set. So in this case, students are asked to decide how many or figure out what % of the days that Jonathan performed this test were bones days. We can take a look at this on the actual tool in just a second. And then they dive into any reasoning errors there are with the argument. And finally, they're prompted to rewrite this argument altogether to make it clarified and more correct. And they're going to use data to support their answer. So let's actually look what this data set looks like. Here's a little GIF of the tests that Jonathan did in order to decide if Noodle had bones or no bones. And I'm going to skip to step 3 so you can see kind of what students will be looking at. Okay, so from this, students can, use, this is kind of the data that they're going to use to decide if this argument is, it has any reasoning errors or if it's incorrect. And although they've been given this sort of pre-set graph state, they can still play around with different tools or different functions within our tool. So they could look at the mean or the median if they wanted to. They could insert the interquartile range, although they're going to get that on the next slide. Okay, but they basically will use this data in order to decide, was Noodle actually popular on his bones or no bones days? And this is a little bit open-ended because depending on what students find in this data, they will have to make some kind of argument. So it's not going to be just like one clear and cut way to answer this question. And then they'll do the same thing on slide 4. So they are now given a little bit more information in slide 4. So they can now formulate their final response and use the data that they have here in order to create that response. So again, a pretty short activity, probably shouldn't take longer than about 15 minutes in a classroom, but getting students really to do that kind of like those deeper like writing skills, that's going through that process of thinking about an argument in terms of data and mathematics, and then being able to actually formulate that into words, which is a lot for kids in 6th to 8th grade. And so they're going to be developing in this skill, and hopefully throughout practice, they get better at it. Okay, Marcy, I'm going to come back to, or Renee, sorry, I'm going to come back to that question. Okay, so that is our critique, correct, and clarify. So our first strategy for our data stories. Our next strategy is called alike and different, sometimes known as same but different, or similar but different. And this is really getting students to, or forcing students to do sort of a comparative analysis between two representations of data. I find this strategy to be appropriate for all grade levels, but specifically in that like elementary and middle grade bands, this is a really powerful strategy for getting students to just talk in comparative language about math. So they're going to be given two stimuli that are similar in some ways, different in other ways, and they can really come up with as many responses as they can think of. There's never one correct answer. And I found that when I use this with my students in the classroom, they would start out with sort of superficial answers at the beginning of the year, and then increase in the complexity of their answers as the year went on. So we are going to look at, if you want to find this in our content library, with the data stories part of our content library, we are going to look at alike and different protein content of food groups. So this is a lesson that is definitely also somewhat cross-curricular. It definitely touches on some science topics, some life science topics. So again, having students build that cross-curricular understanding using math concepts. This one also happens to be a 6th to 8th grade alike and different. We also have another alike and different in our content library that is elementary school. So you can take a look at that one as well after we finish up. I'll show you where that is. But in this alike and different, students are introduced to this concept of energy from our food, and that's measured in calories. And then, there are other things that our food gives us, like protein and fat, etc. So students are going to look at a data set about different food groups and figure out which has the most protein. And then they're going to compare two representations and use, again, that comparative language in order to be able to describe how they're alike and different. So this has similar mathematical content, similar mathematical content to the one we just looked at, just using kind of a different strategy to get students talking and writing about the math. So our little intro, our introduction to the data set, getting students to, again, kind of interact with the data set a little bit before they get started. And then we have our two representations. So students are going to need to scroll down to see both of them. So this is our first representation, and this is our second representation. So as you'll notice, when we, in the alike and different strategy, we are often representing the same thing in multiple ways. So when I would do this with my algebra students, for example, I might give them a graph and a function that were the same function. One was just represented as an equation, one was represented as a graph. So this is kind of similar to that. We have the same data represented in two different ways. And when we represent it in those two different ways, things happen, or, like certain data points disappear, or they are, kind of absorbed within this 5-number summary or this, box and whisker plot. So students will key into a similarity and a difference, and they need to write in a complete sentence, hopefully, or at least those are the directions. They need to write one way that these graphs are similar, or at least one way, and one way that they are different. And if they want to write more, they can write more. Again, I found that, at the beginning of the year, my students would say, something really superficial, like they're different because the top one has fewer dots or something like that, and then as we went on and as we practiced with this strategy, their answers would get more complex. So another kind of feature of this strategy is that it's very like low floor, high ceiling, many different possible answers. And I always emphasize that to students. There is no one correct answer, and your answer is not going to be the same as your neighbor, and that's okay. So this strategy could also be used kind of to prompt discussion in class, have students share their answers, can be used in a lot of different ways as teachers see fit. Okay, I'm going to pause for a second and answer Renee's question in the chat. Are there exemplars for responses that teachers can reference? So yes and no. On some of our data stories, we have submitted sample responses and or like teacher references, especially if those data stories are a little bit more complex. For most of them, however, the intention behind the data story is that they are very open-ended. So student responses can really vary, and that's kind of the beauty of the data story. So we haven't included them on most, but on some of them, you will find that there are, within this teacher overview, there are sort of like teaching tips and or like vocabulary that we suggest that can help teachers as they implement this data story. But our hope is really that the data stories will get used in lots of different ways, and that teachers can kind of use their own creativity in how they use them, and students can then use their creativity in how they answer their questions. As a kind of sidebar, Renee, there are solutions and or suggested answers to most of our activities. Our activities are a little bit less open-ended. So those we do have a lot of solutions and or recommended student answers for. Cool. Okay, moving on to our third instructional strategy. This one's one of my favorites, and one that I also used very often in my classroom. Again, we didn't invent the strategy. This has been out there in the math community, and is a really great one for getting students to think about categorical thinking, and again, sort of like that compare and contrast, and then the ability to make an argument. So in which one doesn't belong, students are going to be given 4 representations. And these representations are all similar in some ways, and then they're all different from each other in some ways. And students' task in this is to be able to explain why one of the 4 does not belong with the other 3. And there's absolutely no correct answer. There's no incorrect answer. Students are really just having to make an argument based on what they see. I like this strategy a lot because it can basically be used for any math content that you might teach. Similarly, I think it can be used for any like data concept or data visualization that we might teach. And it can kind of be tailored to be more or less specific to content by using content vocabulary in the prompts. So sometimes we will add more content-specific vocabulary into the data story. Other times we might suggest that teachers do that on their own. So which one doesn't belong? Okay. So this data story is from a data set that we have from the New York Times Word of the Day. So their learning center at the New York Times puts out a Word of the Day every every weekday, and they give the parts of speech. They also give a definition, and they use it in a sentence. And then they also tell you how many times that word has been used in a New York Times article in the last year. So I like this because it's a data set about an ELA topic, and we're going to look at it using math concepts and data literacy concepts. So really, truly like cross-curricular. And I think it reinforces some of those like early ELA standards like parts of speech and things like that. So this is an elementary data story appropriate for kids grades 3 through 5, so upper elementary. Gives them a little bit of intro and has them perform this quick little okay. Our graph state is missing. We'll check on that. So they would normally perform a little drag and drop of word length. And then one of the early data standards that students work on in grades 3 through 5 is ordering from least to greatest. So this has them order the words by the length of the word and then click on the one farthest to the left. It looks like our graph state for some reason is not showing up. So I will have our tech team figure that out. Okay, and then they're given 4 representations, all of which are very similar again, but also have slight differences that students will pick up on. So here are our 4. First one, we have just a dot plot. It has, all of the different words based on category. This category, they're categorized based on part of speech, so adjective, noun, or verb, but it doesn't tell us how many are in each category. The next one has the same dot plot, but this time there are counts for each category. Next, we have a bar chart, and it also has counts for each category. And then finally, we have a pie chart, and the pie chart has counts for each category. So students will need to categorize these into a category that makes sense to them. So there is no one right or wrong answer to this again. And once they have a graph that they believe does not belong, they're going to complete this sentence. So because this is for our elementary students, we have this sentence frame here. And they would just say, I believe number 4 does not belong because it is the only pie chart, is a sample. They could also say, I believe number 1 does not belong because it is the only graph with no numbers or no counts. You could also make an argument that number 2 doesn't belong. This would be maybe a more like advanced argument, but you could say number 2 doesn't belong. It's the only dot plot with count. Number 3 doesn't belong. It's the only bar chart. So students can and will get creative with their answers, but there are arguments to be made for why each of them doesn't belong. So again, getting that categorical thinking, getting students to perform that categorical thinking, and the mathematical writing. So this is another strategy that gets better with time. Students' answers will improve the more times they do it. Okay, so those 3 strategies are all strategies that are unique to our math data stories. The final 2 are strategies that we use both in our math data stories as well as our science data stories. So claim evidence reasoning, pretty well-known strategy, but I'll just talk briefly about it. So in claim evidence and reasoning, students are given a visualization, so some sort of graph that they then have to write a claim based on, and they will then generate some evidence and some reasoning that support the claim. They may also be asked to evaluate a claim that's already been given to them and provide reasoning and evidence for that claim, or decide if that claim, if the reasoning and evidence that was used for that claim are valid. So this is a strategy that we'll generally use in upper middle school and high school, where students are familiar with that CER framework, which they will generally get introduced to. I mean, some of them in elementary school, many of them in middle and high school. All right, so our claim, evidence, and reasoning data story also uses that data set from TikTok. So this one is about TikTok video likes and comments. This is a data story that we think is probably best suited for students in grades 9 through 12, but students are also learning about linear association in grades 6 through 8. So some of our data stories can kind of be used across those grade level bands, but all students will have been introduced to linear relationships and association by 9th grade. So they'll be familiar with and be able to talk about linear association by the time they get to 9th grade. So in this task, they're going to make a claim about data, they're going to use evidence, and then they're going to provide evidence as to why that, or provide reasoning rather, as to why that evidence supports their claim. So a little introduction to the data. Students are going to look at the data set and perform just some really basic analysis. Okay. And then they're given this graph state, which shows a pretty clear linear association between likes and comments on this TikTok account. So they're going to make a claim about likes versus comments on Noodle's TikTok. Again, very open-ended. There's not one claim that we're hoping students will make, but given that we've provided this least squares line, we're urging them in the direction of this like linear association. But they can play around with this graph state and make some, perform some other functions. They can look at the summary view to see what the slope is, what the correlation coefficient is. So depending on what concepts they've already learned in their math class, they can apply that to the claim that they're making. Then they're going to use some evidence from the data set in order to make that claim, and then provide some reasoning as to why that evidence supports their claim. So taking them through that CER process, this is not teaching them the CER process, but it is utilizing that process in order to be able to talk about some math content, talk about a data set that's hopefully interesting and exciting for them. And our final data story strategy, again, one that we use for our math data stories, but also for our science data stories, is notice and wonder. One of the most well-known strategies, I think, in the education community, can sometimes, I think, be a little bit shallow. And so our hope in the notice and wonder is that we're presenting students with some interesting data sets and data visualizations so that they're able to make kind of robust notices and wonders, or they're at least excited about what they're seeing or interested in what they're seeing, so that they are, excited to make some observations and ask some questions. They may also be asked to use mathematical vocabulary in their observations or their questions in order to kind of connect whatever they're seeing in the data story back to some core concepts that they've learned in their math class. Okay, so this data story is another one of my favorite data stories that we have so far. And this comes from a data set that was collected by the squirrel census. If you have a few moments and you're looking for a little chuckle, I would suggest checking out the squirrel census website. It's really charming and funny. And basically what they do is they partner with the city of New York to get volunteers to go out into New York City parks and, exactly what it sounds like, take a census of the squirrels that they see. So they observe the squirrels, what they look like, their colors, and then they also take observations of all the different activities that they see squirrels doing in the parks. So it's a very like citizen science project, and is, again, I think just like very charming, and hopefully students find it, kind of funny that there are actual, government projects supporting a census of squirrels. But in this data story, they are going to use their knowledge of two-way tables, dot plots, and then fractions, ratios, and percents to make some notices and wonders about these two graphs that we're going to look at that relate to the squirrel census. So I also just love pictures of squirrels. I think they're very cute and funny. But so first they're given this look at the data and all of the different parks where volunteers went out and collected observations about squirrels. So we can see which park had the most squirrel observations on that day, which is, of course, going to be Tompkins Square Park. If students wanted to spend some time playing around with this data, they could also, alter this graph state again and look at other things about this data set. Okay, then they're actually presented with a two-way table. So this might be slightly more appropriate for students in 8th grade, which is when Common Core introduces students to two-way tables. However, it's my opinion that even students in grades 6 and 7, with their knowledge of fractions really, can understand what this table is showing them. So we have 4 buckets here of squirrels that are either foraging or not. So they were observed foraging or not foraging, and eating or not. So this is our bucket of, yes, they were eating, but they were not foraging. They were not eating or foraging. They were foraging but not eating, and then they were doing both. And then we've added another layer onto it, which is we've colored it by whether or not those squirrels in those buckets were approaching humans. So purple if they were not, or pink if they were not, green if they were. So there's a lot going on in this visualization that students can make notices and wonders about. And again, notice and wonder is completely open-ended. So students can really make as many observations as they can. We've prompted them here to list at least 3 observations using academic vocabulary and complete sentences. I always give the direction for complete sentences, but obviously something that needs to be reinforced in the middle grades to write your answers in complete sentences. But again, if they want to list more notices, they can. And then if they want to list more than 3 wonders using academic vocabulary, they can do that as well. So a lot going on here. They can also, if they wanted to, or if teachers wanted to prompt them, playing around with percent. So, if you're teaching percent in 6th or 7th grade, having students, convert between fractions and percents, they can do that. This can be left completely open-ended, or teachers can kind of tailor this and layer more instructions on in order to make it more specific to whatever content they're teaching within their core curriculum. So this one is super short. Students can probably complete this, in 5 or 10 minutes is like a do now or a bell ringer. But getting at some really core data literacy and core math content skills. So those are our 5 instructional strategies. We put out, or we have been putting out 1 new data story per week that aligns each of those 5 instructional strategies in math. I also wanted to just look at look at our content library a little bit, because we do also have some data stories that are cross-curricular. So they cover both math and science content. So if you noticed when I prompted you to go to our content library and look at our data stories, you'll notice that some of these are showing up that are not aligned to the 5 instructional strategies that I just discussed. And that's because they are tagged for both math and science, so they're kind of appropriate to use in both a math and a science classroom. But you'll notice that they are these free activities that we hope that teachers will use on kind of a regular basis in the classroom in order to build those data literacy skills over time. As I mentioned, these data story instructional strategies are better as they get used more often. And so students will mature in their ability to answer these different prompts as they use them more and more throughout the year. And I wanted to also just talk about how we, or some suggestions that we have for how these data stories can get used in the classroom. So our activities, if you are familiar with our activities in our content library, then you know that those are generally like take a class period, and they will aid in teaching core content concepts, whereas our data stories are really used in different ways. So pardon me for just 1 second. I'm trying to reshare something on my screen. Running into the issue of doing too many things on one computer, and now it doesn't want to do anything. while I am waiting for my computer to load, let me see if there are any other questions. Looks like no. All right. Okay, so here's some ways that we recommend or that we have suggested that data stories get used in the classroom. One of the ways that teachers can use data stories is as sort of like a class opener, or if teachers are using the 5E format, to use this as sort of like the engage part of the activity, the hook to get students interested in the concept before they dive into the core content. Data stories are also great as an enrichment activity. So if students are either ahead in the content or need to extend their thinking on something, on a topic that's been learned or on a data literacy skill, then data stories are a great thing to have on hand to be able to do that. As I mentioned at the beginning, they are also great for kickstarting classroom discussions. So although we don't give necessarily in each data story prompts for specific discussion strategies, we do think that they can be paired really well with some discussion strategies that teachers are likely already using. My school was a big Kagan school, so we had lots of Kagan discussion strategies to get students talking to each other. Data stories are kind of a good avenue for that class discussion in math. Frankly, something that I feel like is missing from a lot of math classrooms is that kind of conversation piece. So I love data stories for that. And then finally, we think that data stories could be really great in this sort of like flipped classroom model where students are doing something to kind of preview a topic or preview some content. And they do that as a way to kind of like get ahead or get engaged and excited about an upcoming topic or lesson. Okay, before we sign off, I do see a request to see how these get assigned. So I'm absolutely happy to show you how that happens and then what that looks like on the teacher side. So for all of our data stories and our activities, when you click on that within our content library, you're going to see this teacher overview as I showed you. And on the right-hand side, you'll have some options to assign, try as a student, which is what I did to demo. I always recommend that teachers try the whole data story or activity as a student before they assign it to students. That way, if you want to personalize it in any way or provide additional instructions to your students as they're working on it, additional vocabulary, et cetera, you can do that. And you can also bookmark it to come back to it later. So if you, once you have created a class in your dashboard, then you can assign this activity to that class. So this is the class that I've created as my sort of like demo class. So I can assign it to them. When I assign an activity for a data story to my students, I can provide them with additional instructions. And I can also, you know, if I wanted to count this in my grade book for some amount of points, then I could say, you know, it's worth 5 points. Maybe I don't want it to be worth any points. You know, teachers can customize whatever they'd like for that. And then it gets assigned. So within my dashboard, I can see my class, 7th period, who I've assigned that activity to. And then I can, when students start to complete this activity, I'll be able to see how many students are working on it, how many students are finished, and then I can also grade their assignment once they've done that. So I'll be able to look at student responses and give them feedback on their answers, and I can see exactly what they typed for each step of the assignment. into here. I can also rate this as a teacher. If I liked it a lot, I'll give it 5 stars, however many stars teachers feel is appropriate. This does link to Google Classroom. So for our premium users, teachers, they can link their classroom to Google Classroom and import their rosters that way. Teachers, so in order to create a class, you can also just give students a code. I'm not going to go through the whole process of creating it, but it is incredibly intuitive. Having used many different platforms in the classroom, I think it's incredibly intuitive to be able to create a class and import students into that class. We follow a lot of the same kind of steps as other platforms in order to be able to do that. Okay, I'm going to pause and see if there are any remaining questions. I'll also hang out until sorry, I'm on Mountain Time, so 5:30 East Coast time. If there's anyone else who you find that you have questions, if you don't have questions now, but you think of some later, I will put my email in the chat. I would love to connect with you if you have any suggestions about our data stories, any feedback that you have for them, any questions about how you can implement Tuva into your math curriculum. If you're just looking at maybe ways to incorporate it into an upcoming lesson or unit, I'm happy to walk you through that process of, kind of fitting Tuva into what you're already doing. So please reach out to me. I would love to hear from you. Molly, do you mean to see activities that are tied to standards, like activities that have been tagged with certain standards? Yes. Short answer is yes. Long answer is there are a couple of different ways to do that. So you can go to standards at the top and filter by different standards that we have aligned here. So we have obviously aligned our activities to Common Core, but we also have a few other states that we've started to align our lessons and activities to, not data stories, because data stories don't get tagged as a standard because they're a little bit less tied to content. So these 3 states, Florida, Virginia, and Texas, we've begun the work of doing our alignment. I will say that for some of our grade levels, that alignment is not perfect, and we're still kind of retroactively adding those standards into our tagging. But with Common Core, we have tagged a number of activities with Common Core standards. If there is a Common Core standard where we have an activity tagged, then that will show up in our tagging system. And I know that 6th grade, we definitely have things tagged. So although it's not showing that we have any activities tagged to them, I know that we do. So that's kind of an incomplete way that we're working on for teachers to be able to really quickly find assignment or activities that are tagged to certain standards. We do have, for each grade level, we have, sorry, let me just give my computer a second to catch up. Okay, so for each grade level, we have the major kind of content buckets that we've tagged things to. And within those, teachers can kind of more, like in smaller chunks, look at things that are tied to standards. Does that make sense? So for example, we have a number of activities tied to fractions, ratios, and percent. So kind of within that bucket, you can see we have standards here that are aligned to our activities. So I would recommend, if I were still in the classroom, if I were looking for something aligned to my standards, to go by the grade level here and then kind of like the major topic area. And you'll be able to really easily see the standard within each of our little content cards. Yes, you can definitely search by topic. So for example, this is a topic that might be relevant. Well, yeah, because we have the Super Bowl coming up. I'm not a football person, so this isn't particularly exciting for me. It might be for students. But yeah, you can definitely search by topic. So we have a couple activities for the Super Bowl. We actually have a data story that's going to come out about the Super Bowl. So teachers can search that way. They can also search for like more math related words like linear. So if you were looking to teach something related to linear functions or linear associations, you can search that way as well. Okay, so for premium and not premium, so premium is obviously our paid account. And so with a free account, you'll have access to everything in our content library that is free. So that includes, thanks Renee, that includes all of our data stories. Those are free content, but also we have some activities and data sets that are also free that teachers can use without having a paid account. Obviously, that number is much smaller than our premium account. So if you want like full access to our content library, it is paid. You can ask for a quote for either yourself or a school through our homepage. You just have to log out in order to be able to see the quote section. But yeah, so our premium account just gives you access to everything. But everything I showed you today is part of our free account, our free Tuva account. So you should be able to access all of our data stories without being premium. Absolutely. Yes, I can list the 5 strategies. All right. So Linda, these are the 5 strategies that we use. We use specifically for math data stories. We use critique, correction, clarify, which is kind of a writing strategy, a like indifferent comparison, which one doesn't belong, which is categorical thinking and argumentation, claim evidence reasoning, which you're probably familiar with, and notice and wonder, which you're also probably familiar with. And the lowest grade level that we kind of target is grade 3, which isn't to say that students in maybe grade 2 couldn't do it. I was speaking with a talented and gifted teacher the other day who was teaching a grade 2 student in grade 2. So, and she felt like he could access some of this. But really with the data stories and the emphasis on writing and literacy, probably better suited for grades 3 through 5. But you may have a student who is ready for it. So I would say definitely look at all of our elementary data stories and see, kind of what vocabulary is being used, what's being asked of them in terms of like writing. That might give you an indication of the level of challenge that may be appropriate. Any other questions? Yes, I will happily put my email back in the chat so you can just copy paste it. just Colleen@tuvalabs.com, and we'll gladly chat with you about anything related to Tuva, Tuva for Math, how you can implement Tuva in your classroom, use what we have in some upcoming instruction. Would love to connect with you, so please don't hesitate to reach out. Thank you. Have a wonderful evening, everyone. I'm going to close the Zoom, but please reach out if you need anything.